on the phone that we can't see? Let's see. No. Okay, so I'm not sure everybody knows everyone else. I can speak for Greg, but perhaps we might just do a tiny introduction for people who don't know the rest in the room. So maybe say who you are, where you're based, and what specific thing do you want to learn about the DM stack? Okay, let's go start with Simon.
I'm Simon Krugoff. I'm the science lead for the Square team. I'm based in Tucson, and I'm here in a support role. It is the Square's team's job to develop and maintain the notebook aspect of the LSST Science platform, which is what this group is using. So I'm interested in feedback from users, in improving the system as a whole, and kind of figuring out what requirements what implicit requirements we haven't identified, and how we can meet those.
All right, cool. So you are Mr. LSP. Okay, let's keep going. Keith.
Yes, I'm Keith Bechtel. I'm also in Tucson. I'm the science validation lead during commissioning for LSST. So we have we're doing a parallel learning activity of the DM stack in the commissioning team. So I think it's extremely helpful for me, I think, to see what this group is doing in terms of getting a better understanding of what science users, like how they'll be using the data and what are the things that we should be checking during commissioning, how to prioritize that, and then just learning more tips and tricks for how to interact with the stack. I figure the more different angles we look at this, the better. So I'm happy to learn.
Cool, sounds good. All right, Alex.
Hi, I'm Alex Derlica-Wagner. I'm at Fermilab. It's a good question. So right now I'm interested primarily in being able to run and tweak source detection and photometry and morphological characteristics with the stack. More generally, I'm interested in sort of raising the awareness within science collaborations for how to use and interact with the LSST stack.
Cool, thank you. Okay, so I'm working around my screen here. You can't see it, of course, so it's not fully random. Dara, hi.
Hi there. Let me see if I can turn my camera on too. Can you hear me?
Yeah.
All right, but you can't see me. That's okay. Hi, so I'm Darren Norman, and I guess I'm wearing two hats here. I'm part of the Galaxies collaboration, and I was asked by our chair to, he was looking for people to interact with this group. And I'm particularly interested in how, well, first of all, how the stack works and what it is. I've heard about it for so long. And also just trying to understand how we might use it for some of the projects that we're looking at doing as part of our roadmap in the Galaxies collaboration. And then I'm also the Deputy Associate Director for the Community Science and Data Center at NOAO. And in that capacity, our group is, one of the projects in our group is the Data Lab. And we're also using Jupyter notebooks and setting up tutorials in those notebooks. And so I'm interested in finding out what LSST is doing so that we can be complementary on the Data Lab side. And I know that Robert Nakuda couldn't make it today, but he's been asked also to join, and he is actually doing stuff in the Data Lab as opposed to me, who's just sort of management. So.
Cool, yeah, thanks for connecting him. I saw he joined the Slack channel immediately after being invited. That was great. Okay, cool. Heather.
I'm Heather Kelly. I'm a staff software developer with Slack. I actually live in New Hampshire, though. see, so I work on the camera team and on desk in the computing infrastructure group, particularly handling like DM stack installs at NERSC. I guess my interest is a deeper understanding of the stack. I have also been involved with the DRP pipeline development for DC2. So I've been an installer and user of the stack, but I can certainly use a deeper understanding of all the bits, and I think also keeping abreast of changes do continue to come along. So this is an opportunity to keep track of that as well. And I'm also interested in the science users, seeing what they need, both from the perspective of seeing what NCSA is offering and what we can manage to do on the NERSC side as well.
All right. And Johan, you're muted right now.
Hi, everybody. So let's see. I guess that in the present context, I'm some kind of French foreign agent. So yeah, all that is super interesting, and we are supposed to have potentially a data access center in France, and I'm looking around for good ideas, good first prototypes, and it seems to be interesting what you've been doing with Jupyter Lab. At the CC, it's still not available, but they're working on defining whether they want it or not, so it might be also a case for pushing.
All right, sounds good. Okay, and then I'm Phil. I'm at Slack, member of the LSSC desk, and I'd like to understand more how the difference image analysis works, and how it's configured, how the objects, dia objects are made out of dia sources, all of that, because I'm interested in using time-varying strong gravitational lenses to do cosmology. Cool. Okay. Thanks all. We've got a pretty broad range of interests. I guess at the end of this session, we should come back to this and think a bit more about what we're going to each work on in the next couple of weeks before we meet again. And in particular, what Jupyter notebooks we're going to try and put together. And the reason for that is if you remember our whole reason for being here is to try and learn about the DM stack by writing Jupyter notebooks that teach ourselves and then others about the DM stack. So we're trying to write the tutorials that we want to see. So with that in mind, then we thought today it would be good to take a look at what Alex has been doing, putting together the tutorials that he wants to see. Alex, you were going to show us various extensions and things to the Firefly demo. Wasn't that the main thing?
I think that's, I mean, Simon can correct me, but I think that's probably a good place, a reasonably good place to start off, since it's a good example of sort of the collaboration between people and using existing information. So let me try and share my screen, and I can actually, my plan was to try and go through this from the get-go, which is probably going to run into trouble, but we'll see.
That's cool. I guess part of the reason for all being here and doing this together is to try and solve problems as a group.
Right. So okay. So I think I'm going from the very top. So I'm logging into the LSST Science platform. I think my VPN is all set up, which has been causing trouble. So I'm authenticating.
Actually, I have a question because I've noticed something when I log in. I had an NCSA account before, but very quickly when it's coming up, it'll flash that I need two-factor authorization and authentication. Then it skips over it and proceeds. And I'm assuming everything is fine, but I don't recall setting up two-factor authentication, but maybe I did.
They offer Duo two-factor authentication, but if you didn't set it up, then it just bypasses that. I think probably they'd prefer if everyone set it up, but they are not mandating it.
Thanks.
So I think I'm gonna start a medium instance. I don't actually know how small we can go, but I figure just be a little careful. So then I spawn this instance. And I agree with Greg. This seemed way faster the last time I did it than the spawning on the cloud that we were using before. Okay, so I get dropped into this launcher. I think that what I'm going to do is I'm going to load the Firefly notebook. So essentially this is a visual, it's a navigator. So I'll go into the demo notebook. So this is actually shipped by the Square team. And I'll double click on the Firefly notebook. It should open up. Okay.
Alex?
Yeah.
Did you check out the master branch of that?
I haven't. I can, if you think that would be a good idea.
Well, I'm just seeing files that I expected not to be in the prod branch. Will you do a get status in notebooks demo?
Yeah. Oops.
You are master. I wonder if there's something broken. Okay, thanks.
Okay. Okay. So
This is a notebooks demo
that's right. So
or notebook demo, I guess.
notebook demo Firefly. So just to give people context, if you're interested in figuring out where things are, you can go to the terminal. So this is my home directory. There's a directory called notebooks. Notebooks is where the file browser actually starts as your home directory. And then it's in notebook demo here. And you can see, things that are floating around there. Okay.
Good. I like the way you could see there. You'd already git cloned the DM stack repository into that notebooks folder so that the file manager sees it.
That's right. Yeah. So I decided not to do that while I was playing around, but we can do that from scratch too after Firefly if we want. Okay, so this is a notebook that that Simon originally put together to demonstrate how to visualize images and catalogs. I then went through and essentially made it more verbose, mostly adding text from Jonathan Sick's Getting Started tutorial that's associated with V15 of the stack. I tweaked it a little bit to work both with the Firefly visualization backend and to work with the LSST simulated data. So we have a Twinkles data set that's simulated here. But essentially the information here is just a combination of those two things. So the basic idea is that we're gonna use the butler to access some images. We're gonna use AFW display to display those images, and we're gonna use basically the Firefly client to render them in our browser. And so I don't know what makes sense. We can walk through these, the different cells in order, or we could try and run the whole thing and then see what comes out.
Let's work through it in order so we can follow along.
Okay.
There's probably some people who haven't seen this before.
Yeah.
Yeah. So I guess it would be interesting to get some background. As people's experience and the stack to sort of try and gauge this at the right level. So I know Greg basically when I went through this last time, I went way too fast because Greg had not very much experience with Jupyter notebooks. So we could say a little bit about that first, if that would be useful for people. Is that some people are nodding, but no one's saying anything. Okay, I'll say a little bit. So our hope is that everyone's going to be able to create these kinds of notebooks. And so the notebook is essentially a nice way to combine text and code and images in a way that's sort of in one place and can be executed by different people. And so it lies somewhere between, like a a written manual where you can't do anything, and giving someone a script that they should run and execute and understand on their own. So there are a couple kinds of blocks in this. One is a text block. So if you click on one of the cells that has text in it, you'll see that this label will go to Markdown. So it's using basically Markdown to render this text. So you can go edit things and add like right here. And then if you hit, what is it, Shift Enter, it will render your text using Markdown. And you can use all the Markdown formatting tools, right, which do things like this and many more. So the combination is basically these text blocks. So these first two blocks are text blocks, introducing the goal of the notebook, then saying a bit about where it's meant to be run, what it assumes about your setup kernel. So what's happening here is this notebook actually has a specific instance of Python and associated packages that it's running behind the scenes. You can see what that is up here and change the kernels. But essentially, my understanding is that your kernel is set by default when you, well, it's set in the notebook, but in addition, you choose your version of the stack when you actually log in to Jupyter Hub. So maybe, Simon, do you want to say a little bit about how that configuration works?
He's getting out his cheat sheet.
What configuration? Sorry.
So just the interface between, so when you log into Jupyter Hub and choose an instance of the stack, you're given a set of those instances. Then when you create a notebook, once you're in that instance, it gives you a set of different kernels, and those kernels have some preloaded stack setup that is that's running.
Right. Sorry. Okay. Yes. So, so we basically only have two kernels. One is a vanilla Python 3 kernel, and the other is a Python 3 kernel with the LSST science pipeline stack set up in basically as the first step of starting the Python kernel. There's also a special file that resides in your, yeah, exactly. Those are the two kernels. And then there's a special file called home, right? And so we sort the kernel sources that bash file and then does a setup of all of the packages that make up the LSST science pipeline stack. And then it sources that special file called notebooks.user setups. And so any other further environmental configuration you want to do, you can just put it in there. That's just a bash script that gets sourced at start time. There is a really great set of documentation written by Jonathan Sick that describes all of this in exactly the right level of detail, in my opinion.
So I think that's now linked from the Stack Club repository getting started notes. So if you're there on the README, then you can navigate through to that and find the link to Jonathan's notes.
Okay, so this the basic zeroth order understanding is that once you start this notebook, you essentially have access to all of the LSST stack tools at the Python level. So so what I do here is execute the first code block in this notebook. So what it's doing is it's importing some of these objects, these classes from the LSST stack. It's also importing the AFW display package. It's importing the Firefly client and a number of default Python things. So, okay, I can press Shift and Enter again to run this. When the cell is running, it shows you a star. Then when it completes, it goes to a 1 here. So all of this has now been loaded into the kernel that's running behind this notebook.
Can I ask a best practices question here? So when we're doing these imports, I've seen everyone do this differently. I haven't seen any kind of standardized convention here about, the people do the from LSSD DAF persistence import butler, or sometimes, I guess it depends a little bit on your application, whether you want a specific class, whether you want multiple classes. But every time I've seen people do this, I've seen slightly different choices for how exactly people are doing the imports and how they're if they're importing like part of the package, how they're naming it. Like this, I don't know what the proper Pythonic terminology for this is, but when you say like import numpy as np or etc., I don't know if there's a convention that we want to adopt here, or it's just something standard that people have been using. I haven't found that yet.
I can weigh in, I guess.
It also may not matter or be that important.
Yeah, LSST data management doesn't put a strong, there's no required way to do things. I think and we can mandate something if we like. I think for me, my style is generally that if I am importing, it's just a matter of how many things I'm going to use from that package. If I'm using, in this case, I'm using a single class from that package. And so it's actually less typing to say from that package, import that class, and then use a class later than it would be to say, import LSST DAF persistence as DAF underscore persistence, and then later saying DAF underscore persistence dot butler. That would be more verbose. And so for me, I typically try to minimize keystrokes. So if I'm going to use lots of different things from the package, I import an alias and then just reference the classes downstream, the alias and the class downstream, and if just so I don't have import lines that are 150 characters long. So I guess that's not minimizing keystrokes. I guess it's just minimizing, it's maximizing readability.
The two things that I would add are, one, I think we would like to avoid import stars.
Yeah.
I think that in general, what I've seen as far as convention is that it is verbose enough if you are able to go to the top of the file and figure out where some class came from, so that you can trace back upstream. You don't, every time you use the class, you don't need to have the full verbose string that's saying where it came from. The other convention that I've seen used is the order of imports being basically standard libraries and then down from there. I don't have a strong feeling about that, but I think if we were to do that, it would be more like, this order for imports. Sorry, I just got a phone call that I need to take.
That's okay.
Someone want to lead?
Yeah, I think that I think I've seen that as well. But more generally, I'm wondering now whether we ought to track down the DM style guide and just try and adhere to it a little bit when we're writing notebooks, just to try and help with readability. If we're all reading the DM code so that we can call it from the notebooks, it makes sense to adopt the same kind of style in the notebooks themselves. Another thing is, we can't see it right now, but do you remember at the top of this notebook, the thing that makes this a tutorial, I learned from Jonathan Sick last summer. The thing that makes it a tutorial is that it has this introduction at the top and then this setup or requirements section underneath. So those are two things that are needed for notebooks to be tutorials. So Jonathan teaches us that the introduction section should state the goals for the tutorial, as in your goals by doing this tutorial will be to produce X or learn Y. And then it's just good form to have some notes on what you need in order to be able to run the notebook. So Alex is doing the right thing according to Jonathan's form book. And just to give you a bit of the backstory, Simon, when you had this as a demo notebook, it was pretty terse, right? It was mainly code cells. And what Alex has done is worked through the code, understanding it, and then added markdown cells explaining what's going on and trying to conform to this tutorial style. And I would imagine that in this first phase, the next couple of months, much of what we'll be doing will be like that. So finding good demos and then adding the explanation to ourselves of what these demos are doing, such that the notebooks become tutorial notebooks.
I could imagine that some of the notebooks that come out of this commissioning boot camp might, they might be kind of messy and raw, when we're writing them in the course of hack days, but then to actually document along the lines that you described could turn into something that was more broadly educational.
Yeah, that would be great. I think we'd all like to,
were to take the time to document.
Yeah, exactly. I think that's a really good scheme, Keith. Any other thoughts on the program here, what you're seeing in front of you? As we fill in time while Alex is on the phone.
Just note, I did link the developer guide, Python style guide in the room.
Cool, thank you.
Slack channel.
Oh, and then the other thing that Alex is doing well here, it was at the top of the notebook. He had a link to the documentation. I think this is really important. We've got to do a lot of this because the people who are going to be reading these or working through these tutorials are going to need to see the same documentation that we needed when writing the tutorials. So having lots of hyperlinks to resources is good. Okay, Alex.
Okay, yeah, sorry about that. Okay, so the next step is to create the butler. So the butler is essentially the tool that's used to access LSST datasets. So what we do is we just define a directory where our data live, and then we create a butler instance from pointing at this directory. So Shift Enter to run that. So now we have this butler object. So the nice thing about these Python notebooks is that, if I want, I can, create a new cell here and ask, the butler what it is. And the butler will tell me something about what it thinks it is. And you can, do other who knows what to this object. Right, okay. So, okay, so now one of the things that you will want to do from the butler is to see basically the inventory of the data sets that the butler knows about. And so to do this, we use the query metadata method of the butler object. And so Shift Enter will run that. So essentially what I'm doing is I'm saying, okay, I want to know about these CalExp data products. I want to know the visit, raft, and sensor IDs. And I want to apply a selection on this data set that only returns R-band filter images. So I can hit that and it'll return this. If you want, you can play around here and change this. You can remove this selection.
Can you say something about what those are?
About
visit, raft, sensor.
Yeah, so I can give a little bit and then the LSST people can chime in. So sensor is the CCD. Raft is the set of 9 CCDs on the camera that CCD belongs to. In total, there are, 25 rafts, something like that?
9 plus 12 plus the 4 corners.
Okay. Of order.
I guess that's 25 if you consider all rafts even partially completed.
21 science rafts.
Yeah, okay. And then the visit is, you could think of as the exposure ID. So it's, but that's probably an imprecise definition of the visit. So yeah, okay.
And
And
so
then
is there a place to pull up the definitions of those metadata? Or I don't know if Butler gives you that, or
There's not really, I mean, in essence, they are arbitrary. We've chosen, you need a set of key value pairs that will allow you to uniquely identify a particular grid of pixels in the focal plane array. These are the names we've chosen. And yeah, there's no real, no one signed off on these as the way that people have to refer to things. This is just how we've named things in our data repositories right now. I think probably, to be honest, the word raft will probably disappear from popular usage because it doesn't carry any extra meaning beyond what Visit and CCD provide, other than the fact that we have chosen so far to index CCDs by where they are within a raft. So this nomenclature here, 239, just means OPSIM ID 239. So the 239th simulated visit, basically, of the survey. And then 22 means the raft is in index position x equals 2, y equals 2, which happens in our sensor array to be the very middle one. And then we're indexing the CCD as 1, 1, which means the middle of that middle raft. So that is referring to the central CCD in the focal plane array. I believe in the next version of things, yeah, exactly. I believe in the next version of things, we will end up going to indexing the CCDs just by an integer that we will describe how we define. I know that's not precise.
So I like Dara's question because it gets at a kind of general problem that we're going to face in this club, which is how do we find information like this without asking you? So I like the help function in the notebook. That was pretty good for reading the API documentation. Maybe help on the Butler query metadata might work. But then it would be good to just keep track of the project documents where these things are defined so as to make sense of them. So one source is the data products definition document, but there'll be many others that we should keep track of and make links to and stuff.
Yeah, one thing, these metadata were basically inherited from the camera, and one of the deficiencies currently is that information that crosses subsystem boundaries a lot of times does not get the attention it deserves. It is treated as institutional knowledge, and we should just, it'd be great if the groups like this could call that out, because sometimes if you're embedded, you don't realize that that's how you're treating things.
Yeah, good. So that means that, both in terms of communicating to the project, but also helping ourselves make progress, we may need to make our own cheat sheets as we go.
I also want to point out that even if Raft does go away for you all, like somebody's using it somewhere. So it'd be good to know what it is.
Yeah.
Yeah, I would based on past experience, for DCAM, there was one numbering scheme that was used during construction, and there was another numbering scheme that was used after construction. And in the end, the rafts are individual electronic units, and often they are a unit that could potentially fail or have features altogether. And so that information ends up being useful down the line. I don't know how many times I've looked up what backplane a specific DCAM CCD is on. So,
good point.
Yeah. Okay, so the question of what a CalExp is, we haven't really dealt with yet. And this is another thing that that is probably not as well documented as it should be. But essentially, it's a calibrated exposure. So it's had all of the instrument signature removal steps already run on it. In this case, these were simulated data. And so it's actually had had things actually applied on top of the simulation to mimic the real instrument, and then removed back off using the instrument signature removal. So there are other, I don't know what I could put in here. Maybe the image. Okay, so I mean, there are other values that you could put in here that essentially define data products at different levels of processing. So I could put catalog. What is the name for catalog I could throw in here?
SRC.
SRC, yeah.
SRC.
I would actually, along Alex's point here, I would very, very high on my wish list would be a cheat sheet listing all of the available data types and the keys that you need to uniquely identify one, or the keys that are needed to pass to the butler to to get even a set of data objects of individual data objects of that type.
Is someone
Right.
keeping notes on this
Yes.
this meeting?
I think I mean, we've talked about this with Simon before, and we know that there's like a YAML document that specifies this, but it's not actually like documented in the way that someone who isn't familiar already with the details would understand.
Yeah.
So I think that would be somehow a document that, or even just a infographic or something that somehow summarizes the different data types would be extremely helpful. I don't know that that's collected in any one place at the moment.
Actually, I just like to find the YAML document.
Me
There's a
too.
point, yeah, at least for me.
I'll see if I can find it.
That'd be awesome.
I know it's come up in previous discussions with Simon.
So a good way to handle this kind of thing is going to happen a lot as we take part in this club. So we should think about what to do when this happens. I'd suggest that what we're doing here is identifying an issue. So someone should start it in the Stack Club repo. And we can then use that to figure out how to make the cheat sheet that we want to see. Because in some cases it's going to be, make a markdown file in the repository for our own use. But in other cases it will be, identifying the right piece of the DM code so that we can submit a pull request against it. Right? When we saw the help query metadata method just now, it would have been really nice if that had just told us all about the different data types. So it could be that that's the right place to put a cheat sheet. So we'll need to do some figuring out.
Query metadata can't do that because my understanding is it is instrument agnostic, and so the names are specific.
Good. So there's going to be discussion about best ways to do things, isn't there? Sorry.
So yeah, and I'd also push back on, like, I love the idea of putting issues up there and advertising stuff, but I really want to enable people to just do things also. So I don't think anyone that wants to put together a markdown file or even post the YAML file, right, should just do it. They shouldn't, assume that they need some kind of review on that pull request, or that they need to wait for confirmation that this is the right way to do it. I would much rather get the information there.
Oh, sure. I'm just saying that as we do that, we need to tell each other what we've done. So a quick Slack message sometimes works, but they go past quickly. But the other channel we have for ourselves is the issues and pull requests. But for sure, yeah, just go ahead and do it, and then via the pull request thread, we'll see what you've done. Oh, Simon.
Yeah, I don't know who's heard and who's not, but we are revamping our data IO abstraction system, and the key value pairs are going to become much less ad hoc. So we are going to, across all instruments, settle on one name for what a coherent set of pixels is called. I don't remember whether it's detector or CCD, but this will get somewhat easier in the relatively near future.
Cool.
Okay,
All right, let's keep going, Alex.
Let's keep going. All right, so let's see what happened. Oh, I changed something and it broke, but all right, so now what are we going to do? We're going to grab an exposure. So this is basically our inventory of exposures. And what I'm going to do now is specify, okay, so now I want an R-band filter, specific raft, specific sensor, noting here that I think CCD actually didn't work if I replaced sensor with CCD. Right, okay, so it broke. Whereas above, I was able to intersperse sensor and CCD. Okay, so this is then returning a calibrated exposure object or a CalEx object that has these characteristics where it's a specific CCD of a specific raft of a specific visit in R band. And I think I probably don't need this R qualifier. Let's see. Okay, and this object is, a wrapper around, this is not just the array of pixel values for this CCD, but it's really an object that wraps this with a lot of other metadata, such as the masking, the image masking, the weights, as well as other metadata, PSF information, maybe even could be here.
WCS and the calibration, I think.
WCS, okay, yeah. And you can get each, so get WCS, and you can get each of these pieces of information from this object. Okay.
Okay, I have a really stupid question, and I'm going to have to go soon anyway, so I will not have a lot more stupid questions. But one question is, so when you said you didn't need to use R there, is that because you had filtered on R in the first place?
No, it was because I think the visit is uniquely defined. So if you think about
I see. Okay.
right, exactly. So like each exposure has one filter.
Yeah.
So because I specified just the visit number, it's fine.
Gotcha. And then when you couldn't use CCD there, but you could use it above, is that a bug, or is that because of what you're using to call? Like, I don't understand why it worked one place and not the other.
I think it's
I think probably the bug is that I shouldn't have been able to use CCD up here.
Gotcha. Okay.
Yeah.
All right. Thank you.
Yep. No, good questions. Okay, so now we create a display. So what we're going to try and do is plot this, this image that I now have, this data associated with a CCD image that I have. So I'm going to import display. This is actually not, we did that up here, I think, and named it something different. So we probably actually want to fix this in the notebook. But here we've created this AFW display. Now we're going to configure the Firefly backend. So something to note here is that in the tutorial that you'll find associated with the stack, the default backend is DS9. So if you were doing this on your local machine, you could essentially pop up a DS9 display and talk to it directly. But because we're doing this remotely, we need to do some web-based visualization, use some web-based visualization tool. Okay, so set up for the Firefly backend. So run that. And then they create the frame that's Fly, and that's now being embedded here in the notebook. Okay, so we're gonna come back to this later. This is awesome, by the way. Yeah, go ahead, Simon.
So that server is unrelated to this notebook in particular. So you can take like those two cells and open them in another notebook and put them side by side, and it actually is a pretty good effect. So I don't know if you've played around with how these notebooks, how you can change the orientation of the notebooks, but they do kind of snap side by side if you want, if you drag one out. Yeah.
Oops. Let's do.
You have to drag it on top of the other window. Yeah, there you go. There you go. And that will snap side by side.
Mm.
And so now I can go and, create a new notebook, move it over here.
Yeah, there you go.
Okay. And then I can take this cell.
Yeah, and you'll have to import OS.
Okay. Import OS. And then take this cell.
And you'll have to import iframe.
From where?
I don't remember. You'll have to go up to the top of the other notebook. It's with the IPython utilities.
Oh, yeah.
Yeah.
Okay. And then we'll take this and put it here. And now I'll close this.
Yeah, now everything will show up in both panes, but it's kind of easier if you have them side by side. Yeah, you can make that a little smaller. I don't know, if maybe fit a little better. I'm not sure exactly how Firefly reacts to the size of the frame that it's in. It doesn't seem to auto scale, but it's something that we'll ask about and look into.
Mm-hmm. Okay. And so then what we'll do is set the backend. I don't know what happened here.
You must have skipped executing a cell.
Yeah. So
It means the server.
Well, there is a breaking change to the
oh, hey, David.
the client API. There was a breaking change introduced in last week's weekly, or the weekly that was built over the last weekend. So it wants a parameter called URL instead of host. Yeah, we wanted to kind of make the initialization a little more rational.
I think my kernel is from v15, and also this all ran for me an hour ago. So I think probably.
Actually, I think when you started this one, it was the most recent daily.
Yeah, I think you grabbed the daily, Alex. It's working. It's working for me right now. I'm running on I think the most recent weekly.
Okay, great. Okay, so yeah, so that's my fault. Okay. So maybe the easiest thing. So the word on the street is that's URL now?
Well, then you have to tack a /Firefly onto the end. Or better is you can eliminate it. It actually reads it from an environment variable now. So you can actually take out that whole argument. And
Okay.
I predict it will work. Let's see. Yay.
Okay. Yay. Okay.
Okay, I have a question again. So when that didn't work, and you were all talking about what instance of the kernel you were running, where did you load that? That was back when you started.
That's right. Yeah. So that's when I originally logged in. So.
Okay. But I guess I'm asking, how did you choose which one?
I usually go to v15 by default because that's sort of, I figure that's stable, or at least stable enough, if not the most recent. But other people could answer.
Yeah, I kind of think we have to do that. I mean, the stack is still a moving target, and we have to have some stability to work with. So I think being, trying to remember to use the v15 makes a lot of sense.
Okay, thank you.
Something's not right.
Yeah, something's not right.
Oh.
Hmm.
Hmm. So what I'm going to do, just in the interest of moving forward, is log out and log back in with V15, unless someone has a...
No, you go ahead. I have a question for Simon while you do that. So why, you're showing us here the two Firefly displays next to each other, one in one notebook, one in the other. Are you saying that the same display will appear eventually in both, right?
Yes.
And why is that a useful thing?
Oh, I'm not saying that it is necessarily. If I were to, I would have suggested that we move these two cells out of the notebook on the left and put it in the one on the right and use that as our display. It's just, we have them in one notebook currently just to have one coherent notebook that you can read through. But if I were doing this, if I were actually trying to do analysis, I wouldn't have those cells in the notebook on the left at all.
I see. So you're working through the notebook on the left, and then the display is staying in the same place on the right. Okay.
Yeah. Yeah. So this is one thing that we are bumping up against, is that notebooks are wonderful for doing kind of organic exploration and, you know, capturing epicycles when you're going back and re-executing cells and things like that. But for dynamic and interactive visualization, it's actually a little uncomfortable because things scroll off your screen and then you have to come back to them. And so we're trying to find ways to allow those interactive visualizations to occupy same space, basically.
Got it.
That's interesting. So when I restart and run all cells, does it do both notebooks? So they go...
No, this is another interesting thing about the Jupyter Lab. The fact that the menu is at the highest level it makes you think that those menu items affect the entire environment, but in reality, they only affect the things that have the focus.
Mm-hmm.
So like it mixed together in those menu items, there are things that affect the terminal as well as the notebook, and it just grays out the ones that are not relevant to the focused element at the time. I do think this is something that's on their radar. I don't know what they're planning to do to address it.
Okay, so I have to actually go in 3 minutes. Well, and now post equals server.
Hopefully it'll just work.
Yeah, this will be great success.
Yay! Oh.
No, file not found. Oh, maybe my change up here wasn't actually as safe as I thought it was.
You have a calibrated exposure in hand.
Yeah, I thought so.
It needs a colon, not an equals.
Oh, yeah. But okay, but I do. You're right.
So David Shoup, who people saw pop on, wasn't around to introduce himself, but he's a liaison for the Firefly client. So he's an excellent resource.
Yeah, okay, thanks. I have a suspicion what's going on here, because I think just a few days ago on this cluster, Adam Thornton had changed from one Firefly server to two Firefly servers. So I'm a little bit worried that sometimes you get, because I've seen the same error. Sometimes you it's not going to the right server. What the server that does work, that's at NCSA. Well, I think another one to try is LSST-demo. Where we also have two Firefly servers behind it, but I think things are set up right so that you don't get routed to the wrong one. So, but it might work this time when you.
Okay.
So just try executing cell 10 again.
Thinking.
Okay.
So we think this is a Firefly problem?
It's a configuration problem, I think.
Yeah, if you change your server to lsst-demo, yeah, let's try that.
But you're saying, Alex, that it worked for you earlier today.
It did, yeah.
Okay.
That should have done something. Okay.
Yeah, and it's working for me now.
All right. How about we switch adventurously to Keith's sharing screen because I think Alex has to run.
Bye,
Yeah.
Alex.
Bye.
Alex, thanks very much. This was great.
Yeah.
I too am going to take off.
Okay. Thanks a lot, Dara. See you next
Bye,
time.
Dara.
All right. So here we are looking at Keith's computer.
You see that?
I'm gonna have to run relatively soon as well. But-
Okay. Thanks a lot, Simon. So Keith, if you're up for it, we could continue stepping through Alex's notebook and see what he's trying to understand what he's done.
All right. Sure. Yeah, that's
This in a way, this is all of our futures, right?
Right,
Picking
that's
up other
right.
people's notebooks and turning them into tutorials by figuring out what's happening.
Yeah, so in some sense, so it when I first ran this, it didn't come up with all of these displays, right? It just came up with the Firefly ready,
Mm-hmm.
and then I think it was not until here that the image appeared. Sorry, the image appeared. So MTV, I'm not exactly sure what this stands for, but it seems like this is basically a pixel level image viewer tool, from what I can tell from the other demos that I've seen. And
It's not just that, right? It's put some other things in the display as well.
well, so I'm not. Yeah, I'd have to see. I'd have to look at. So this is somehow like the final. Okay. So it's actually these next line, this whole sequence of lines. I think we're essentially editing the display here.
Okay.
So I forget which of these actually came up with the initial MTV command.
Oh, I see. Probably it's just the image display. I think MTV is, like you say, it's the pixel viewer.
Yeah.
It also overplots the masks.
Yeah, by default it seems.
Yes.
Huh. So the calyx knows about a catalog of some kind.
No, it's got a mask plane.
Ah, okay, good.
So these are. So I guess that's a question. So all of these blue. This is a mask plane, or this is showing the footprints of the individual sources, or is this one and the same? Like one of the bits of one of the image planes is somehow telling you every pixel that is considered to be part of the footprint of a source.
So if you click up in the top bar, there's a little icon that has a 6 next to it. Not one bar down from that. The one with all the icons. Yeah, go right. Until you hit the one, it's got a little blue stick.
This here.
Yeah. So.
Oh, I see. So this is it's the detected bit.
Right. So any pixel that's flagged as detected is blue in that. And cosmic rays will be fuchsia. Pixels that are within a half a PSF of the edge will be yellow, and anything that was interpolated because of saturation and so forth will be green.
So do calyx always have this stuff, or can you get calyx that don't have detected planes?
Well, you can get calyx that don't have the mask plane set, but any calyx comes with a mask plane and with predefined meanings on those masks.
Okay. That's sweet.
Yeah, you could construct a calyx. Well, so a calyx in and of itself is something that by definition has come out of process CCD, which assigns the masks. You could get an exposure, which is the class that is instantiated to make a calyx. You could get an exposure with a mask plane that's set to all zeros.
Got it.
So, okay, so there's another question here. It looks like there is not a source for every blue detected. Each unique blue detected region, there's not a source that coincides with that.
Right. So you have to read the text, unfortunately. So we display sources two different ways. And Alex, when
maybe Alex has done some sort of selection on the sources here further down.
Right. Well, yeah. So keep going down. So cell number.
Yeah.
Keep going down. He's looking at the source table, and then so cell 17. He's plotting sources, but he only plots the first 100.
Oh, got it. Okay.
And it happens that the sources are ordered by pixel ID, basically from the 0 up to the top right corner. And so that's just how this particular detection algorithm runs. So you get sources only in the bottom few rows of the image. But you could take that slice out and it would plot all the sources in the catalog, and you'd see at least one for every blue region because some of them will deblend.
Okay, I see now. Yeah, I guess it's a little bit tricky looking at this without having worked. It's a little bit tricky looking at the final product, I guess.
Yeah. And then the catalog that you see on the right is selected to just contain sources that were used in the PSF determination.
In that, I'm trying to see. Oh, I see. In that
so
here. Right here. It's the show table, but it's already been filtered here.
Yes, exactly.
Okay, so we're somehow looking at a completed notebook here. Is this because you ran all cells, Keith?
I ran all the cells just because I wanted to see if it would work.
Okay. Okay, so
maybe it'd be helpful. Maybe I should restart.
Well, I don't know. I mean, there's lots to...
And then we can see what each of the individual cells did.
Yeah, I think I'd be interested in that. What do other people think? You have questions about what you see here? Or? Johan, we're taking up your French evening here. What are you interested in? Drinking pasties in silence. No, here we are.
Oh, it's fine. I ran this one when I connected to Jupyter Lab. It's an interesting one. I think one of the things that I noticed is that we had a small discussion like 15 minutes ago about raft sensors and visits, and it's getting much more frustratingly painstaking when it comes to tracts and patches, which come, of course, a little bit afterwards in the processing. So in some respects, this is important what we are doing now, but it's going to be worse to explain along the way. So you may want to remember that and not spend necessarily a lot of time on the things which are reasonably easy to. I'm afraid that we are going to spend a lot of time on things which are not necessarily the most complicated ones that we are facing.
Good.
That's the only thing that I noticed listening to this. I mean, for me, the Firefly was fine, and it's an excellent introduction for people who don't know a lot about the stack. But we have to keep in mind that time runs short when it comes to going deeper into the things which are really a little bit messy right now.
So would you say that a good follow-up notebook to this one might be a tutorial that takes a from a data set that has coad images, so not calyx but coads, and
Well, not
tries to
necessarily.
visualize
No.
tracts and patches and explain.
Right, so Coad would be a big step forward. Or already doing a little bit of interesting job on the astrometry is not totally trivial.
Mm-hmm.
For instance, what Dominic has been doing recently is actually taking him a lot of time when the sample of calyx and reference catalog entries is a bit large.
Mm-hmm.
And that's very interesting because there you start really understanding, in effect, what the stack is doing when it's processing information and tries to match, for instance, the astrometry.
Yeah, and I guess any tutorial that tries to explain what the astrometric calibration is doing is also going to want to, make those explanations using this kind of viewer, right, to show what's going on using a Firefly viewer.
Absolutely. So in terms of foundation bricks, it's perfect.
Mm-hmm. So Keith, you're getting ready to show us something here. Simon, you have to go. Thanks a lot, man.
Well, actually, I have to go as well.
Thanks, Johan. Good to see you.
Yeah.
Good. Yeah, we're into our second half and now exploring with Keith.
Yes. So okay. So I was just playing around here.
Yeah, I was hoping to see what this plot was. It looks like
but it looks like you can zoom out and in, and this is maybe going to show us some brushing and linking.
Oh yeah, when you click on the row, it shows the point on the plot.
So Keith, if you have that box tool selected, you can drag a box on the plot. So inside the plot, drag a box.
Oh, okay, and I already have it selected.
Yeah.
If I do this.
Yeah, and then click the little check mark in the plot. There you go. And now it will select those same points elsewhere.
Is it linking with the image now?
Yes.
So if I can zoom out.
Zoom to fit. Yeah, there you go. So the yellow one.
So now we see all the orange boxes.
And there's a similar mechanic on the image. So if you select the box up at the top there, going right, yeah, that one. Select rectangular, and then click the check mark.
Oh yeah, look at the bottom.
Yep.
Different points selected.
It's
cool.
great that this is now integrated into the notebook. I'm really happy to see this. I think the next level of functionality that we would want, and maybe it's already demoed here, I haven't actually looked, is the ability to get these IDs out. Basically to be able to select those rows if you want to do some further analysis on them.
I don't believe that's functionality that exists, but David could correct me.
Yeah, not in this Yeah, I don't think we have that in this interface. There is something to save the table, but I don't know if it'll save the filtered table.
Are we seeing the filtered table now or the full table?
I think it's highlighting the rows.
Yeah. So
would be my guess.
Yeah.
Is that so? I think that this table was actually created. Basically, the selection used to create that table and the selection used to plot the sources were different. I think. Because here we're selecting the first 100 entries.
So the boxes are actually the ones that are plotted with the show table down there.
Yeah, that's right.
The ones above that you plot with the dot command show up as little circles.
Oh, I see.
They're just different ways of putting annotations or markers down on the image. And I actually find this mechanism much more useful because of the brushing and linking and such. But I think we do need the functionality to bring that back into the notebook. Don't forget to click the check mark.
Oh, I see. Okay. I select and then check. Okay, got it.
Another thing that I think we'll find ourselves wanting is selections on being able to provide criterion to parameters in multiple places, like doing a selection on the image, and then also selecting in the parameter space as well. I think will be something we'll want to do. All right, I really do have to run. Sorry.
Simon, thank you very much. See you next time.
Sure. Bye.
So this demo looks to me like it's kind of generally useful enough that we all ought to work through it in order to learn this tool. Just because this Firefly visualization tool looks like we're going to be using it again and again.
I think that's right. I mean, I guess I think of this notebook as being, yeah, exactly, as being the Firefly demo of how to use this particular visualization tool, which the project has been putting forward as the workhorse for this type of visualization.
Yeah, so I think we'll do well to become skilled experts in its use.
Agreed.
Okay. Is there anything else we should be looking at in the notebook code itself? We've got things that we'll see when we work through it on our own. But is there anything worth calling out while we're here together?
There's other aspects that aren't directly related to Firefly.
Mm-hmm.
For example, this is where to get the sources that were detected in this individual visit. So this is basically showing an example of how to get a different data set type.
Mm-hmm.
And then to browse the contents of that is an AstroPy table.
Yeah.
Right. So that's just something. So this is not directly related to the Firefly, but another example of how to access a data set type.
Right. It's a jumping off point, right? Because just looking at this table here, we're seeing all the columns that are in the table. And, if we have tutorials in mind that we would like to see to do with, for example, photometry or PSF properties, it's giving us keywords to search for, to go look through the stack code to figure out what the stack is doing, and then prepare notebooks that somehow explore those pipeline stages that produce them. There we go.
I think it's this will show you all the different column names. Right. So you can figure out what's in all the different columns that are available, and they're numerous.
Yeah.
There's also the concept of slots, which are specially defined. I don't know exactly how to describe them in the way that the LSSDM group would prefer to have them described. But the way I think of them as the slots are placeholders, for instance, like getting the coordinates, where there's many different ways of measuring the ARIA index, for example. But there's a slot called, I think you can see it if you go to the schema here, and it will tell you, I think they're listed at the end. Exactly, where they tell you that for these specifically named, that are commonly accessed quantities, which of the columns that they should correspond to. So it's a way of abstracting information that you would want, where there's potentially many ways of making that type of measurement, but you want to know what the default option would be, for example.
Okay. So if I was to ask for the centroid column, what I would get is the base _ SDSS centroid.
That's right.
Okay. Cool. So there's going to be a lot we can get out of this notebook in terms of starting other notebooks, but also understanding other demos we find that maybe don't have the explanations of what's going on.
Yeah, although I might actually separate those concepts. Like it might be good to have. I mean, it might be good to focus this notebook specifically on the Firefly interface, and use other notebooks for exploring.
Oh, for sure.
All of the information that's available in these different data set types.
I think that's exactly right. I think this one is going to be a useful work of reference for us to get started on other notebooks.
Yeah, I tend to agree. I think that this one started to grow really big, so splitting them into smaller ones would be good.
Yeah, so this one actually isn't one of ours. If you remember at the start, this was in the notebook demo folder. So the Square team put together a terse demo, and Alex added a bunch of markdown cells explaining it, and then submitted those changes back to Simon and the Square team. When we're working on Stack Club notebooks that maybe are built off little demos found elsewhere, I think it will still be useful to return to this Firefly notebook for pointers.
I'm just looking through. I hadn't had a chance to look at this notebook in advance, so I'm just looking to see what's in it.
Actually, I was going to suggest we've got 35 minutes left of our 2 hours. I think probably a good use of the next 20 minutes or so might be for each of us to try and have a go at bringing it up and working through it. And if we see things that we don't understand as we're doing that, or if we hit problems, then the rest of us will be here in the room to try and help debug and fix things.
So actually, I've been doing that, and I ran into this. I thought I ran into the same problem that Alex was having, where the Firefly was responding that the file could not be found, and I made the change. I think that David had suggested earlier, and I made LST-demo, and it started to work. So I'm just curious. When Keith's running it, he's running it and using the server pointing to LST-LSP dev.
Yeah, apparently so.
That's right. And I would need to figure out exactly. I'm pretty sure that I loaded the most recent weekly. It'd be great if I could figure out exactly which version I loaded. I see a lot. This is looking at when I typed env into the all the environment variables, and it looks like it's bringing up a lot of things that say V15 on them.
Yeah. If you do if you did EUPS, EUPS list and try LST_dev dist distrib. Sorry, it'll tell you which one you have set up. I think this is how it would work. Sorry, I can't
Underscore distrib, is it?
Yeah.
Did I spell it wrong? Sorry.
No, you said it's underscore, not dash.
Oh.
Sorry. It's hard working in real time like that. Okay, so yeah, it looks like you have
here we go. The weekly 1819.
Yeah, so that is the weekly that's before this breaking change was made. So that's why it worked.
So V15 should also work, right?
Yeah. Yes.
And that's the kernel I'm using is version 15. So I'll go back and I'll try to rerun it again.
Okay. So others trying this, it sounds like V15, but then switching the server to LSST-demo instead of LSST-LSP-dev is the thing to do. So Keith, you can carry on sharing your screen so that people who are watching at home have something to look at as you tool around. But I'm going to have a go here at running it too.
Well, it might actually be more beneficial for someone to see it from the start, because at this point I've run all the cells. So it might actually be more useful for if you were to share your screen as you're working through.
Okay. I can try that.
I'll stop my share.
Okay. So now everyone can watch me attempt to make VPN work. And then in the meantime, I guess people who are on the call, have a go yourselves. All right. So any connect. So we didn't show this at the start of the meeting, but there's now a bunch of notes in the repo, in the getting started folder, that points you to the docs for how to do the VPN. I have to admit, this was my first time ever using VPN. Okay. All right, here goes. So here it's restarting a session that I was already running. But that was, I assure you, it was in using the V15 stack, because that's all I ever do. And so let's go back here.
But we could see that if you did that EUPS command, right?
Oh yeah, let's do that. EUPS list lsst oops t underscore distrib. I have no idea why that. Perhaps I didn't do the shell command, the bash setup. Okay, never mind. So let's see about making Firefly run. Okay. All right, here we go. So I'm just going to start paging through the cells. And make the butler. There's a query. Getting a collects. Now, make the display. Okay, so I'm going to try it with LSP dev then, and then see whether this will work. There's my Firefly frame, and then display the collects. So I think, yeah, there's the file not found. No. All right, it works for me.
I think there's a little bit of randomness to it as to whether you get the right one of the two servers. So we'll have to fix that up.
Okay, I see. Gosh, it's exciting to be on the LSST science platform at such an early stage. Okay, so that the display command then was this one, AFW display, mt.mtv, and like we were saying, just shows the image with the mask plane. Oh, and there's this pink circle in the center. So let's keep going, and we'll have to keep scrolling back up to see.
I think that might literally be the center.
Yeah, it looks like
it's just telling you what the center is. It's like a crosshairs.
Got it.
Sorry,
Okay.
what's the MTV command for?
MTV displays the image in the Firefly display.
Okay.
It looks like it's showing the full, I guess, sensor visit image. Now, okay, so now we're into improving the image display. So, like some transparency to the masks. and then an 1/8" stretch. It's going to make the image look better. It's pretty cool. And then I guess Z-scale sets the min-max limit sensibly. So this looks more like the image that we were seeing.
Yeah, that looks great.
Okay, so that's going. So then here we are in the masks. So it's going to loop over the different masks and tell us about them. So this is what's going to get overlaid. Detected in blue. Okay, so now this is where Alex gets the source table. Good, so the key then for getting a source table object is to pass in this string src. And then this src object is a source table. And it has 2,662 sources. And now it's, that just made an AstroPy table out of the source table so that it will display nicely. So that was the thing we were looking at a minute ago with all the columns. Okay, so now we're going to overplot sources. And this is where Alex selects just the first 100 so that it's not some huge number. It takes a long time. He's saying 100 sources preferentially located at the bottom of the image, which I guess is the result of the order in which they were detected. No, there they are, orange ones down there. So I guess I can zoom in on this. Oh, and it moved because I panned it with my mouse. So I'm dragging the image around within the box. Okay. So where did we get to? Oh, and then you can clear markers using this erase function. Okay, good. So then this bottom section is about using the Firefly client to make plots as well. So this is where the extra things are going to appear up in the display. So you need a fits file to pass to Firefly. Okay, so now Alex is selecting just the sources that were used to fit the PSF. So that's Calib PSF used. And we have a new subtable called PSF source. And then write that out to fits. Okay, so source tables have a write fits method. And now FC is the Firefly client, I guess. Yep. And that has an upload file method. So now Firefly has the source table loaded into it. And then this is where we can now do a show table in the Firefly client, this FC object. So now when we scroll up, we should see the source table appeared in the display. Whoops. Cool, there it is. Now sorted by ID. I guess that's a filter. Huh. So we could be filtering the table in here and it will change what's shown in the display, I guess. But to be honest, yeah. See, until there's a way of exporting the selection back into the notebook, I feel like I don't want to do that because otherwise it will just my stuff will get lost. So I think for now, I'd rather do the selection in the notebook, write out the fits file, and then read it back in, or upload it to the client. Okay, so I'm not going to filter the table up. Okay, so then there's style options. What's this? Oh, okay, so we're going to make a plot, but the first thing we're going to do is write the axis labels. Good. We know what we're doing. It's going to be aperture flux divided by model magnitude versus log of aperture flux. And then to make the plot, we have to specify the data in this trace1 dictionary. Huh. Okay, so there's some syntax to understand here. So the X and Y items, quantities, what we want to do is take the aperture flux, that's that thing, base circular aperture flux, divide it by the base Gaussian flux, and then plot that. But what we actually do is we make a string that contains this formula and then has this funny tables : thing in front of it. And then say we want a scatter plot. And give it a table ID SRC. I wonder if that has to be the same as the SRCs that are known to the image display. Okay, so let's make that dictionary. Yeah, go ahead.
Yes, yes, it has to be the same that you called it when you for upload file. Oh
Yeah,
wait, no, I'm sorry, for show table.
Table ID at line 23.
In here?
Yeah. See how you gave it a table ID?
Oh yeah, table ID. Okay, good. So they need to match. Okay. Okay, so this is what we do. We make this dictionary and then we pass the dictionary through to the show chart method of the Firefly client using this data keyword argument. So if I do this, this is going to make the plot in the display above. So now we see why Simon was telling us about having a second display, Firefly display in a second notebook next to it, so that we don't have to keep doing this scrolling. Here it is, tiny plot. Now, can I change the size of the Firefly client? If I just do this, will it break all the things I've got in it? Let's try it. So I'm going to make it long and thin to give more space for plots. Oops.
Oh,
so it wipes the display when you resize it, or when you remake it.
What? Yeah, it's like a reload. Because if you, I mean, you can also just run it in a different browser tab.
Yeah. That was what Simon was telling us. But just then I realized that if we're going to have an image display and a plot, I wanted to make the display bigger. So now I get to redo all of this. How far down did we get? Using Firefly client directly. So here's layout dictionary. There's the trace1 dictionary, and then that was the plot line. So now we should get, there we go. It's a bigger image display. And now I can make this plot nice and big. Cool. Okay, so now we're more or less at the state that we were in when Keith was giving us the look ahead to what was in the display. Now, was there more to this? Okay, let's read Alex's conclusions. guess it's good to have one of these little sections at the bottom of every tutorial so that we summarize what we've just learned. So key takeaways. Use the butler to read and write data. The display module gives a flexible framework for sending data to image displays. Use the Firefly backend because it rocks. Exposure objects have image, mask, and metadata. Yep. And masks are overlaid automatically. We've got a table out, source table out, and worked with it a bit. The AstroPy trick, that was good. The as AstroPy was good for the nice display of the table. And then we did some specific plotting of objects in the same Firefly client next to the image display. Okay, anyone any problems working through that yourselves? Or any thoughts on what you're seeing here? I guess I was struck by the thought with Johan about making a follow-up to this with the coads, but that would take some investigation into the coad images.
Well, there's a similar CalExp object for the coad.
Mm-hmm.
So I think that in principle, if you just wanted to do the same exercise but using a co-added image as opposed to a single visit image, that would be relatively straightforward.
Okay. So I was originally I was wondering about doing that just as a super simple test of data availability and image display. So I may take a look at that.
I think that you would need to use a different data set or else create coads from the Twinkles data set, because I think that this small sample is only 10 visits, 10 single visit images in each of the filters, but they haven't been pushed through the co-edition process yet.
Okay, so it could be an opportunity to go explore the HSC data set, something like that.
That's right. Yeah, you could. So you can do this with the HSC data set now.
Actually, so Keith, I think you know about this. I was going to ask you, in this project, is it shared data?
That's right, shared.
In this directory, there's a few data sets for us to play around with. Have you looked at these much?
Yeah, I've looked at them a little bit. The HSC is a full reprocessing of the HSC Public Data Release 1 that was done about a month ago. So with a more recent version of the stack than was available at the time of the initial HSC Public Data Release about a year ago.
Okay.
And that does include co-added images and catalogs derived from those co-added images.
So this I would think was a great data set for us to.
That's what we're going to use for the boot camp next week.
You are? Okay, good.
Yes, yeah, that's the plan.
Okay, so this might be something for us to focus on when starting to think about the tutorials that we each want to put together. Does it include, you say it's a full reprocessing, does that include the difference image analysis?
I don't think any of the difference image analysis is run on the HSC data.
Okay.
Should have said full reprocessing at the level of what was done for the original HSC public data release.
Okay. But not full reprocessing.
But not everything. So that would that's something. Yeah, that's something that remains to be done. I think is to create a suitable data set for tutorials that is using difference image data products. And that might be something, I guess I was hoping that was something that we might be able to create next week.
So Twinkles ought to be able to do it. Like the difference imaging analysis has been run on the Twinkles images. And in principle, if you've got a coad and you've got a calyx, then you can take the difference.
I think that's. I mean, I'm sure that's true. I just haven't seen an example of how to do that.
Okay. So, given that my my stated interest was difference image analysis, I guess maybe I should spend some time looking into that in the next 2 weeks. See if I can make a DIA.
I think that'd be, yeah. I think it'd be really useful, and I know that some of the folks in Washington are interested in this as well.
Yeah. Okay.
Of creating a suitable, basically identifying a data set and creating a tutorial that shows how to do the difference imaging, which includes making the template, and then working with those products that are produced by the difference imaging analysis.
Yeah. Okay, so talking of the notebooks that we want to see, I wonder if it's worth us doing a couple of things. One is, if you have thoughts already about what you'd like to make, now is a good time to air them. We can also look at the little doc that we put together on the with the topic list for the Stack Club, with our various notebook seeds that we thought might make good starting points for generating notebooks. Let's see, Greg, Heather, David, did you have thoughts already about what you would like to make in your Stack Club time?
I didn't have any specific things. I think that the whatever we covered today was a huge amount of, and I have to think a little bit about what's next.
Yeah, I think taking the time to go back and work through the Firefly demo should probably help a lot with, in parallel, thinking about what you want to do next.
Yeah, I really like that I could see the screen sharing, because there's some things that I could see people doing that was not completely obvious to me.
Mm. Yeah, and things go past fast, don't they? If you're watching somebody who has done a lot of notebook development in the past, they have all these tricks that they just pull out without thinking, and it's good to stop them and ask them what they're doing.
Yeah, that's why it's so useful to have it recorded, so you can go back and see exactly what happened.
Yeah, that's right. We'll be watching this, binge watching it on repeat all weekend. Heather, a thought springing to your mind about what you'd like to see?
I'm not sure yet. I'm not sure yet. Yeah. Ah.
Could you bring up the list, actually?
Go ahead. Sorry.
I could bring up the list. Yeah.
Yeah, I mean, it might be just helpful for people to
to
know what the range of options might be.
Heather's problem, of course, is that she's running this task force in the desk, which is to implement the entire data release processing pipeline.
Exactly.
So there's a lot of things on her to-do list. Okay, so this is the seedling notebook stock that we made. So Greg and Alex basically went through, having had some starting thoughts about what kind of notebooks we might try and make, either how-tos, like how to use the bits of the stack to do specific things, or sort of pipeline recipes that pick on a particular stage in the LSST processing pipelines and sort of dig into it to see what it's doing and try and understand how the algorithms work. And then with that in mind, they made this list of topics and tried to look for existing tutorials, either demo notebooks or HTML web pages that could serve as starting point seeds for the development of a tutorial notebook or a few notebooks. So how about we just page through this and see what they come up with. So first we see visualization, a lot of which is covered in that Firefly notebook, but there are almost certainly other things to do here. Then they've got processing of single images, where there's a bunch of detailed topics to try and understand, including detrending, calibration, ISR. And this is the one that Alex picked up on as something to look into, and he started looking at this process CCD HTML tutorial that Jonathan Sick wrote as a possible starting point. Then we have source extraction and catalog access, including how the source detection actually works, what the deblender is doing, possibly how alerts are generated. There's moving objects, how they're treated. There's a whole bunch of things to look at in terms of the source detection. And there's a few seeds here, including a deblender demo that Robert Lupton wrote. But I think we must be missing a lot of seeds here. I'm sure there are more things that have been done already in this general area. It's a big one, source extraction. Image co-edition, no seed yet found, but clearly important for many aspects of both the alert production and the data release processing. And then there's some more detailed topics. So sky background estimation. This was featured in the tutorial that the DM group put together for last year's PCW in Tucson, the Project and Community Workshop there. And we figured that looking at how the stack treats the sky background, what it does with it, would be a useful thing to understand. Similarly, we've got PSF estimation, how this is done, what the PSF model looks like, how do we work with it. There's a good demo here from Robert Lupton that could be turned into a tutorial or split off into a bunch of different tutorials that pick up on different aspects of the PSF modeling. And then, of course, once you've extracted sources, what the processing does with them next. There's a whole range of interesting things. So photometry, the model fits that are done, measuring galaxy shapes, extracting light curves, even just making objects out of sources is something that we need to understand. And so there's a few different seeds here. Again, I'm sure we've not captured them all yet. Johan flagged up astrometric calibration as an important thing to understand. I know that he mentioned Dominique, that's Dominique Boutiny, within the desk, has been looking at this carefully. So there could be something from him that we could pick up and turn into a tutorial to understand what he is doing, and then also what the LSST data facility will do. And then photometric calibration, likewise, this is something that we'll need to understand. And here, this is another of these HTML tutorials that Jonathan Sick wrote. In this multiband analysis one, there could be some good starting points for understanding the photometry in more detail. Okay, so then the last two topics that
I feel like there's a conspicuous omission here, which is building the templates and doing the difference imaging and working with the difference image products.
Yep.
I guess I would also say that in some of the photometric calibration, I mean, I'm trying to think of what maybe this is partly a question of scope of what I mean. Is the objective here kind of teaching people to to understand where the photometric calibration comes from, or teaching photometric calibration in the context of the LSST stack? Because presumably some of these things will have been kind of done in the sense of calibrating the absolute photometric scale, or galactic extinction is a very big topic, where the simplest answer is, just take these multiplicative coefficients, but then there's a question of where do those come from? And
yeah, so
and then you're getting into questions of how are the band passes defined? I mean, it's something that can explode very quickly and is almost a science discussion topic unto itself that's independent from the DM stack, or could be.
Yeah, exactly. So I would say that in this club we are primarily students of the stack and also of the science pipelines. So what I would want to learn is, what does the LSSD data facility plan to do, and how will it be done using the DM stack? And so a notebook that just lays that out and works through an example of it would then lead to investigations of, well, exactly which algorithms are being employed and how do they compare with alternatives and that kind of thing. But
these topics would be constrained to the scope of what is aspects of the problem that are being handled by the DM stack.
I think so, yeah.
Okay.
Then the wider conversation, the wider science conversation about what's the right thing to do, how is this going to affect my investigation of galaxies? I guess that ought to be happening in the science collaborations, but we'll need this information about, well, what is the stack doing, that we can try and understand while we're here.
That seems like a really good way to divide it.
Cool. Okay, so I've got a note here about difference image analysis. I will work that up, since I just said that I wanted to work on it myself. So yeah, if any of you see other gaps, I think the best thing to do is just either add them in or flag them in the Slack channel or on an issue, and we can refine and extend this topic list as we go.
Phil, I have a question. At some point, we talked about working closely with the commissioning team. Do you think that there's anything that we're missing here that the commissioning team will find very useful and valuable?
Oh, well, certainly Keith should speak to that. But I'm remembering now, Greg, you were away and you were not here in the first half hour, where we said or Keith pointed out that some of the things that the commissioning team is going to be doing, as in the notebooks they're going to be making, might themselves be useful seeds for the Stack Club to take on. But in terms of things missing that commissioning needs, what do you think, Keith?
I think honestly, I think all of this is extremely helpful just to have it documented. I guess a lot of what we're thinking about from the commissioning side is more like functional in terms of the immediate demands that we need to address, but that's different than actually documenting these things carefully for a broader audience. And so I think just having gone through all these topics in a systematic way from top to bottom, I think would be extremely helpful for us. Our work right now has been more oriented towards the specific tests and applications that we'd be doing in commissioning, rather than a really top to bottom thorough explanation of the entire stack.
Yeah.
So I think it's we have very similar goals, but maybe a different order and emphasis in how we're approaching them.
Yeah. So perhaps we can come from two different directions and meet in the middle. That's
right.
Okay, thanks for pointing out, Phil, that all I have to do is to just replay the beginning of the of the recording and have my questions answered.
Okay, so we're coming to the end of our first 2-hour session. Sounds like for most of us, we've got some homework to do with working through the Firefly notebook, and then as we do that, think about the tutorial that we'd each like to see. It also sounds like the next time we meet, we should probably spend a good amount of time looking at the things that are coming out of the commissioning bootcamp, so that can help us think about, well, what do we each want to do next? So maybe, Keith, when I see you in Tucson next week, maybe we can plan that a little bit for the week after the bootcamp, which is when we're next due to meet.
Sounds good.
And then in the meantime, we can just keep in touch by Slack and the issues. All right, everyone. Good to see you all. Thanks for coming. I hope this was useful.
Okay, thank you.